Okay, so there was a question about this motion example that I provided here, and the question was whether there is a translation implied in this picture, and therefore whether that translation ought not to also be represented in the mathematical definition of the motion. Yes, the way I've drawn the picture, it appears like there is a translation, but I just drew those two, the current and the reference configurations apart simply to be able to draw them properly and show them. So strictly speaking, if one wants to go with this particular picture, one should also add a translation, a constant translation vector to the mathematical description of motion. Okay, so to include translation, one would say that x equals phi of x comma time equals some constant vector c plus everything else that we wrote out there, right? Tan gamma function of time x2 e1 plus x2 e2 plus x3 e3, right? That would be the general representation of that motion. What I wrote on the previous slide out here would be more accurate for the case where the reference configuration was somehow superposed on the current configuration and had not really translated away. But for this would be the right motion. This would be the complete description of motion, where C belonging to R3 is a constant vector, right? In particular, we would write C maybe as some C1 E1, because the way I drew that picture, it was only the E1 component that was being changed.